Have you ever tried to make a comic or any kind of visual story with AI art tools? If you have, you probably know the feeling. You hit this incredibly frustrating wall. You get the perfect first panel, it looks amazing, but then you go to make the second one and suddenly your character's hair is a totally different color, the room is laid out all wrong, and your story just collapses. All right, let's get into why that happens.
I mean, that's the big question, isn't it? We've got these unbelievable image generators that can whip up stunning pieces of art in seconds. But the moment you ask them to create a sequence, a story, they just fall flat. How is it so hard for them to remember something as basic as what a character looks like from one panel to the next? And there it is. That's the one-word answer. They're amnesiac. Every single time you generate an image, it's a completely new event. The AI has absolutely zero memory of the panel it just created. It's like it's starting from scratch every single time, which, as you can imagine, is just a recipe for storytelling chaos.
So let's really dig into what this amnesiac AI problem means when you're actually trying to create something. This is the big one, the fundamental challenge that anybody trying to do sequential art with AI has to figure out how to get around.
Okay, so here's the breakdown. First, you've got the obvious visual inconsistency. You know, the character's scar that jumps from their left cheek to their right. Then there's the lack of spatial coherence. Like a window is on the left wall, and in the very next panel, poof, it's gone. This forces you into this soul-crushing cycle of tedious iteration where you're just smashing that regenerate button, praying you get a lucky match. And on top of all that, your text prompts give you almost no precise control over the camera angle or composition. It's just a frustrating mess. So how in the world do you fix this? Well, the first idea seemed logical, if you're an engineer. But it showed a massive misunderstanding of how creative people actually work. The first attempt tried to solve the problem by basically turning the storyteller into a programmer.
Yeah, the first thought was to have creators do things like draw patrol routes for their characters or build these complex behavior trees. But come on, a writer or an artist doesn't think like that. They want to give high-level commands. They want to set a destination for a character, give them motivations, not sit there scripting their every move like a video game NPC.
And this led to a critical realization, the one that really changed the whole project. The point isn't to make creators wrestle with clunky, technical tools. The goal, the real goal, is to empower them, to make them feel like a director in complete control of their vision, not some frustrated game dev stuck debugging code. So with that in mind, they made a complete pivot, a total 180. This was the start of a story-first revolution. It meant throwing out the old tech-first approach and completely redesigning the workflow to match how real stories are actually made.
And right here, this is the big aha moment. The creator realized the fundamental mistake was thinking the process should be, first, generate a big world, and then figure out how to make a comic inside it. But that's totally backwards. Real creators start with the story. They write the script, then they build only what the story needs, and then they direct the scenes. The story has to come first. It dictates the world, not the other way around.
This new insight created a brand new pipeline. Step 1, you develop the name. That's a Japanese manga term for the rough draft or storyboard. You work with AI to get your script just right. Then the system automatically pulls the key characters and locations from your script and you build them out. Only after that's done do you move to the screenplay phase, where you direct your shots panel by panel. And finally, you render. It's a workflow that finally puts the storyteller back in charge.
Okay, that's great for the big picture. But what about all those tiny, maddening details? We can keep the same character model, sure, but what about the intricate lace pattern on her wedding dress? What about that scar that stays on the right cheek but keeps changing its shape? Those little things can still completely break the illusion.
The answer to this problem is a really, really cool concept they call the digital backlot. This is the idea that takes us from just general consistency to making sure every single little detail is perfect from one panel to the next.
You see, most other tools are basically just playing whack-a-mole. An AI generates a dress with a missing sleeve, so the user has to manually in-paint it back in. But in the next panel, the dress's pattern is totally different. They're always just fighting the symptoms, the little mistakes, because their system has no real memory of the objects themselves. They're treating the cause. This required a totally different way of thinking. A competitor's tool says, generate a character wearing a wedding dress, and every time the AI just imagines a brand new dress. This new model says, generate a wedding dress, period. You perfect it, you save it as an object. Then you tell the system, now put that specific dress on the character. It's a huge difference between a vague description and a permanent physical object.
And that's the digital backlot. It's an asset-first strategy. You're not just generating random scenes anymore. You're building a digital props department. That wedding dress, it's now a persistent, reusable asset. That hero's unique sword, it's an asset. It's exactly like how a real movie studio has a backlot with costumes and props ready to go for any scene.
And you could see how this creates a massive competitive advantage. With the old prompt first way, objects have no real identity, so consistency is always going to be low. The user's workflow is just in paint and hope for the best. But with the asset first model, objects are persistent, consistency is high by design, and the creator is actually building a valuable library of their own assets as they work. Okay, so we've got the story figured out. We have consistent objects, but what about action? What about movement? How do you make sure that if a building collapses in panel 1, the rubble is still on the ground in panel 2? That requires the last and maybe the coolest piece of the puzzle.
The huge breakthrough here is realizing that the world can't just be a static 3D set. It has to be a living, breathing simulation that you can pause at any moment. It needs to be a world that understands time and consequences. That's the only way to get true sequential action.
And the way they do this is called the simulation snapshot method. The best way to think about it is that your comic is a film strip. You're not creating a bunch of disconnected photos. You're actually capturing individual frames from a continuous movie that's always running in the background.
Let me walk you through how this actually works. At time 0, you set up your shot and capture panel 1. Let's say it's a giant titan standing at position A. Now, for the next panel, you don't just drag the titan to a new spot. No, you just advance the timeline forward by 2 seconds. The game engine simulates the titan's walk cycle and automatically moves it to position B. Then you just pause the simulation, find your new camera angle, and capture panel 2. The movement is perfectly consistent because it was simulated, not guessed.
The results of thinking this way are just incredible. You get perfect continuity automatically. That tree that fell, it stays down. You can automate complex action sequences and then just scrub through the timeline to find the most epic moments to capture. It turns the creator into a director of not just space, but of time itself.
So, when you put all of these pieces together, you get this final, unified vision. It all starts with the story. From that script, an invisible 3D world is built. Inside that world, you create your digital backlot of persistent assets. You direct action through an AI-powered simulation, and the whole time, you stay in the director's chair, using simple, intuitive commands.
If there is one single thing to take away from all of this, it's this. The entire strategic leap comes from this one insight. You have to stop asking an AI with no memory to generate vague descriptions over and over again. Instead, you create persistent objects, and you start placing them in a world that can actually remember.
And that really brings us to the future, doesn't it? This whole system solves a huge problem for creating things like comics, but it opens up an even bigger, more exciting question. If a story world can finally have a memory, if it can understand cause and effect, what kind of living, evolving, interactive narratives could we create next? What comes after this?